So, welcome. We're going to spend some time here talking about Fast Reroute. My name is Joe Soricelli. I work at Juniper Networks. I'm in the professional services group now. I've been kind of bouncing around, but in a past life I have done some training. So it'll be a little strange for me to be stuck to a podium. I'm usually the guy that wanders around the room and talks and stuff. So if you see the hands going, that's sort of the substitute for that. Before we get started, if you have questions, please head toward the microphones. Better? Okay. So if you have questions, head toward the mics so that we can catch it up on the audio for the recording. That way everybody can hear as well. If not, I'll try and repeat. So just remind me of that. So let's dive in here. So this is listed as an intermediate / advanced. I couldn't really make up my mind how deep we were going to end up in the end. But I can tell you that we're not going to be going over the basics, right? So I'm expecting that everybody knows all those things, what RSVP is for, why we're using it, what labels are, et cetera, what the messages are, how we extended the protocols, and whatnot. Now, having said that, if you don't understand something, please, give me a holler. I enjoy questions. I like questions. It's the trainer in me. Besides, we don't have that monster of a group, so it shouldn't get too unruly. Okay, so typically the first question, right, you get the whys. Why do we need this? Why do we care? And, the answers are going to vary depending on your particular situation. Most people that I would talk to would say that we're talking about traffic protection. And we're not talking about traffic protection from the standpoint of an overall network, okay? Because if you have LSP set up on the network and you have an ingress router, it's going to forward over the LSP. And if that one breaks, it has the opportunity to set up another one. And we'll forward it over that one, right? If you can't find one, it'll just forward via IP, right? So we're not necessarily throwing packets away. It's not that we're not getting places. But what we're worried about is the time it takes from the failure of the LSP to the time the ingress router knows about it. Okay, there's a delay there. Could be really, really short. Could be really, really long in network time. But during that time frame, we're actively sending packets down this LSP. Okay, so I'm sending them down. The LSP is busted, but I don't know yet. So I'm effectively throwing those things on the floor. Okay, so that's what we're trying to protect. Those amount of packets that are already inside the LSP tunnel. Maybe we have contractual needs for this. Maybe we have SLA needs for this. Maybe we're doing sensitive traffic, voice and video stuff. The reasons can vary, or maybe it's just because. It's cool, right? Cool, we want to turn it on, let's do it. I've been in networks where that's, hey, why do you have this feature turned on? Because we want to try it out. Okay, wouldn't have been my choice, but I've been there. This bottom one here I kind of threw in just sort of for the heck of it. I'm not really advocating that we run a network right now without any knowledge of IP in the middle of it. For anything at all, not VPNs, because that's kind of a constant. But I have heard some discussions about it. And so if that's the case, now if your LSP goes down, you don't have an IPv4 backup to be forwarding packets. Right? So now it really is critical to always have a path available to be forwarding stuff on the network. Okay? So, having said that, the only real requirements we have for MPLS is RSVP. Okay, we got to have traffic engineering, because all the nodes in the network have to be able to see the entire path, be able to see the paths around the current LSP, to be able to set up these protection things we're going to be setting up to do Fast Reroute. Okay, so TE is a requirement, so that means RSVP. That means obviously we're running an IGP that has extensions in it, et cetera, et cetera. Okay, so no RSVP, no TED, no Fast Reroute. Simple as that. All right, so to get started, we'll talk about some terms, so that when I'm yapping about stuff in the future, we'll all understand each other. Then we'll look at how an LSP signals to the network that it would like to have the services of Fast Reroute. Because all the routers have to know along the LSP's path. Then we'll look at the two different kinds of Fast Reroute. We have one-to-one backup. We have facility backup. Those are the two main varieties. And then within that, we have some subsets. And at the end, I've got a sample diagram, and I got some packet dumps so we can actually see what some of this stuff looks like in pseudo real time. I also do have a connection provided that everything stays connected to some actual live router, so if we want to play around at the end, we have that option as well. So, any questions before we get started? All right. It's late. Everybody had lunch. Right? Cookies are settling in now. Okay, so one-to-one backup. This is a mode of fast reroute where every LSP that you set up in the network gets its own dedicated set of backup paths. Okay? If I create LSP1, it has its own set of backup paths. If I create LSP2, it's got its own set, and 3, its own set, et cetera, et cetera. Okay? So what this is really doing in the long run is not only associating things on a one-to-one basis, but we're adding quite a lot of state to the network. Okay? A lot of RSVP state out there to maintain all these LSPs and all the backups that are associated with just their one particular LSP. The main form of protection for one-to-one backup is node protection. Okay, so node protection here is, I'm a transit router along an LSP. I've got a next downstream transit router, and egress is further on down the stream. I'm concerned about failures of the network link between myself and my downstream partner, but I'm also concerned about failures of that router itself. Could be its routing process goes away, could be RSVP decides to not work any longer, whatever. Okay, but the link and the node downstream. So I'm trying to get a path in the network that will avoid both of those devices. The only exception to this, of course, is the penultimate node and the egress node. Okay, because the egress node doesn't have to go anywhere, it's the egress. The penultimate node, which is one hop up, can't necessarily go around the last node because it needs to get there. Right? That is the egress router. So we'll do what we call link protection for that. We'll talk about that in a little bit. Now the paths that we're going to set up in a one-to-one backup scenario start at every router along the path, so the ingress, all the transits, and the penultimate, and they are destined toward the egress router. Okay. Now, in a small network, like the ones I have my packet capture from and the ones I'm attached to, we're going to pretty much go from that ingress or transit routers and go directly to the egress without coming back into the path of the original LSP. But in a large real network, chances are your path that goes around the downstream node is probably going to connect back into the original LSP path somewhere further downstream. Doesn't always happen, but chances are it's going to happen. So the reason that, we'll see in a bit, the reason that we're headed toward the egress router is because we're taking the RSVP session information off the LSP and using that to set up our backup paths. Okay, so that's why we're headed toward the egress, because that's the destination. So during a failure mode, what the router that notices the failure is going to do is it's going to do just a plain label swap. Okay, it's going to get label in, it's going to do a label swap and shoot it out this backup path that we've established, and eventually it's going to get to the egress router. Okay, and I got some slides, we'll talk about that. But that's one-to-one backup. Okay, that's one major variety. We're talking about node protection there. So here's just a nice little graphic. I got an LSP running from the far left of the screen here along the southern routes to the far right. And after it's established, we're going to set up backup paths. Okay, so the ingress router and the two transits, or transit penultimate, however you want to talk about it, are going to set up these alternate paths in the network. Okay, they're headed toward the egress, so we don't really have much choice here as far as where we're going to go. So if we look at the penultimate, we're going to go up to the middle and over to the egress because that's the nice shortest path. From this transit node, we're trying to avoid this downstream router here. So if we're going to go up to the middle, there's one hop away to the egress. Again, pretty straightforward. The real difference is on the ingress router. Okay, because if you notice, we're obviously trying to avoid the first transit node, but we don't go into the middle and then kick back out to connect back into the LSP. Okay, we're headed toward the egress router. And from the perspective of the ingress, once we get into the middle of the network, the egress is shorter, one hop this way as opposed to two hops that way. Okay, so that's kind of the main mindset. You got talking about one-to-one backup, you're talking about going to the egress router. Okay, so the other main chunk we got to talk about is facility backup. So this is a many-to-one paradigm where you can have many LSPs in the network using one facility backup path. Okay, so whereas then we had one-to-one, obviously it's one-to-one. So now we have facility, we have multiple things can use one backup path. Of course, we're going to do node protection, just like we just talked about. But in addition, we can set up just link protection, which means that every router in the path no longer cares about its downstream link and the downstream node. We're only concerned about the next downstream node, or sorry, the next downstream link. Okay, all we're concerned about is that link failure. So we're trying to avoid that link from having problems. So we're going to set up these paths, one per link. And if we have multiple LSPs running across that link, they'll all use this backup path we've now established. Okay, so we get this, we're going to see a great savings and reduction of RSVP state because we're only going to be setting up one backup path. Now the main difference when it comes to label operation for facility backup is that here we're going to do a swap and a push. Okay, so we'll see in the slides when I get to it, when I actually have some values there. The router that notices the failure is going to take in label, it's going to do a label swap for its next downstream node, but then it's also going to do a push for that backup path. I'm going to shoot it around the backup path, and it'll get to my next downstream node, and then it'll be business as usual. It received a label it knew about because it allocated it in the first place, or off down the LSP. Okay, so I got some further slides, so we'll kick back to that. So here's a little graphic of link protection. Okay, I've got my same LSP running from the left to the right. So the ingress router now, instead of worrying about this node and the link, it's only concerned about the link. Okay, so notice we go into the middle and we come back out to the next downstream node. We're not headed toward the egress. We're headed just to avoid that link. Same thing from transit up and down, and then from the penultimate to the egress. Okay, so it looks a little bit different than we saw with one-to-one. Yeah?
In this scenario, and the one that you presented earlier, I know you're just trying to provide that solution. But I do notice that you're sending everything through that one router there. That might become a vulnerability there in the network. In general, I mean, you can try to balance which ones you might use as a backup.
Okay, so the question had to do with my nice simple graphics and everything going through the middle. Yeah, it becomes a congestion point, maybe single point of failure. If you just let the protocols run by themselves, they're going to find the best path. Okay, so if that best path happens to congregate on a node, you're kind of stuck there. You do have some options to have these backup paths take certain specific routes. So in that case, you can engineer things to sort of avoid a congestion point. Okay, so you kind of have both, I guess. Okay. So this is link protection for facility backup. We also do node protection. Okay. So we're avoiding the link and the node. Notice again, especially from the ingress router's perspective, we're not going to the egress, right? We're going to the next downstream node beyond my neighbor. So I'm going to avoid this first transit node, and I'm going to shoot myself over to the penultimate node in this case. Okay. Transit node's avoiding the penultimate, so it goes up. Well, the next router downstream is the egress. Okay, so we just go there anyway. The penultimate router doesn't really have a node to back up, right? We saw that before. So it's just going to do plain old link protection. So the point of local repair, the PLR. This is the router that is the ingress for your backup paths. This is also the router that is going to take all that action. It's going to be doing the label swap or the label swap and push depending on what kind of backup you're using. It's the router that's going to be notifying the ingress router that there's a problem. So that's the PLR, the point of local repair. Down at the bottom here, the error message that we're going to send back to the ingress is a path error. So is this going to be tearing down the LSP? If I send a path error, is that a type of message that tears the LSP down? Who says yes? Come on, play my game. Who says no? Who doesn't care? Who's not listening? Okay. The answer is no. Okay, it's an error message only. It's just going to alert the ingress that there's a problem. What the ingress router does at that point is totally up to the ingress router and up to its configuration and up to its implementation and up to what software you're running. So there's a whole bunch of variables that go in there. Okay. If we sent a tear message, that would have torn it down. Okay, all we're doing is sending an error message. Okay. So a protected LSP. This is the original LSP you set up in the network. Okay, you've gone to the ingress router, you've configured how to get to the egress, and off you go. That's the protected LSP. That is the one that's going to be requesting protection. And when protection is available, it then becomes a protected LSP. Pretty straightforward. Now, the next couple have to do with whether you're running one-to-one or facility. Okay, so if you're doing a one-to-one backup, the backup paths that you establish in the network are technically called detour LSPs. Okay, because you're detouring yourself off the main path and to the egress router. Okay, that's your end destination is the egress. So basically that's what it is. You're just taking a detour through the network, but you're still ending up at the egress. That's the same end goal. And again, that's a one-to-one protection thing. In a facility backup, okay, you're doing link protection, you get a bypass LSP. Okay, because you're trying to bypass either the next downstream link or the next downstream node. So for link protection, we get a next hop, because I'm going from myself and I'm trying to get to the next hop. I'm setting up a bypass, and that's my destination. Okay. When I'm doing node protection, I'm trying to go to the next hop. Okay, so I get this next hop bypass LSP thingy. Right? I'm not trying to get to the next hop in line. I'm trying to get to the one beyond that. Okay, so we call it a next hop. Generally speaking, when I'm talking about facility stuff, I just call them bypass LSPs. If you need to get really detailed about what you're talking about, it's either next hop or next hop. Okay, so in the facility mode, where we avoided the next downstream link, and we connected back into the original path of the LSP. Okay, we didn't go right to the egress. We went to some other point in the LSP. That router that makes that reconnection is called the merge point. Okay, because you're merging the bypass back onto the original LSP path, the protected LSP. Okay, that's a merge point. We also have a concept of a merge point when we talk about one-to-one. Okay, if you think back to the graphic I had for one-to-one, where all these routers were setting up Detour LSPs to the egress router. They all went through that middle node, and they all went through that same link to the egress. Or in your case, it would be going this way. Well, when you get to that router, you've got 3 sets of path information that are all the same entity. They're all the same source and egress tunnel. They're both the same tunnel ID. You'll see in the packet dumps that they all contain the same RSVP session information. So they are basically are pieces of the same thing. So in that case, we can combine those into a single LSP running from that point to the egress router. That's a detour merge point, because you're merging detours together. I got some graphics, hopefully that'll be a little clearer. Okay, questions? Got one-to-one, facility, node protection, link protection, detour LSP, bypass LSP. Okay. So now we're concerned about how does the protected LSP tell the network that it wants protection. We've got a couple different ways to do that. The first thing we're going to talk about is an actual object for RSVP, Fast Reroute object. We're going to use this in a one-to-one scheme. Okay, so one-to-one scheme, we're talking about node protection. We're going to set this Fast Reroute object inside the path message. And this is going to alert all the routers along the path of the protected LSP that it wants one-to-one node protection. Now, we also have pieces in here in this flag field to signal for facility backup. Right now, we're not really using that for facility backup. We have some other methods for doing that we'll talk about in a second. So for right now, for what we're going to talk about, we're using this for one-to-one and it's node protection. You can see here that we have some information that can help us set up these detour LSPs. Okay, we've got priorities, set up and hold priorities. By default, they'll inherit the ones from the LSP, but if you want something different, you have that option. We have a hop limit. Okay, how many hops can I take on this detour before I get to the egress? Okay, if it's too many, maybe you don't want it to set up at all. You can set up some bandwidth reservations. Okay, so if you're protecting things like maybe voice traffic and you have a bandwidth reservation in the network, you may want to inherit that. Okay, so we can stick that in this object here. And then we have the include and exclude for administrative groups or link colors or affinity classes or whatever you want to call it. Only take the gold links, stay away from the silver links, what have you. Okay, so the detours will take these pieces that you're signaling in the original path message. So here's a nice little cheesy graphic, right? It's in the path message for the original protected LSP. That's the important point here. Okay? Don't use it for the detours, just for the original LSP. So if that's for one-to-one and node protection, when it comes to doing facility, we're going to be setting some flag values in the session attribute object. This is already an object that's in the path messages. We had a couple of flags defined already, but now with the extensions for Fast Reroute, we added some flags. So the first one we have, hex 01, is the ingress router saying, I'd like protection. Okay, I'd like to do some protection. This allows the transit and the penultimate, transit routers, to set up the bypass, and it also allows them to avoid the strict ERO that's generally in the path message. Okay, hey, it's okay to detour this thing if you got it in a Fast Reroute scenario. Okay, if we're doing either link or node protection, we're going to set this. Okay, because we want to do local protection. We have a separate flag we'll see in a second just for node, but for link and for node. Label recording. This is going to be helpful in about 20 minutes. Okay, so if you can remember label recording, you'll be good. Basically what this says is when you are, assigning your labels, not only send them upstream in the reservation message, but also put that value in the record route, so that all the routers along the path not only know the path, but know what label was assigned from every router. Okay, so that's what label recording does. So Hex 04, we've had this one for a long time, shared explicit. Okay, this allows multiple entities within the same RSVP session to share bandwidth reservations. Okay, so we don't double count bandwidth. So that's generally a good thing when we have all of this state floating around and we're trying to do merges and things. We don't want to be counting up 10 or 50 or 100 megabits for each one of those in the network. Okay, we'd want to have them share resources where available. Okay, Hex 8 is bandwidth protection. So by default, the backup paths we establish will not do bandwidths. If you want them to, they will. You just got to ask nicely. Okay, so turn on that flag. You'll reserve some bandwidth for your backups. If you turn this on, then we're going to look for the information in one of two places. If there's a specific bandwidth assigned in the fast reroute object, we'll use that. If not, then we'll just inherit the bandwidth value from the protected LSP. Last but certainly not least, node protection. Okay, Hex 1. So not only do I want to do local protection with flag number 1, but I want to do node protection specifically. Okay. So this is how we're going to signal stuff for facility, either node or link. Now, regardless of which method you're using, once you've established the LSP, once you've told the routers along the path you want to do protection, regardless of what kind you're doing, each of those routers are going to consult the TED. Okay? It's going to figure out whether I need to go to the egress router if you're doing one-to-one, whether I need to go to the next downstream link or the next downstream link. It's going to find that, in the TED. It's going to run CSPF if you've given it things like include or exclude or bandwidth. It's going to come up with an ERO, it's going to give the RSVP, and we're going to signal the path. Okay, so once we've gotten to this point, things happen just sort of like normal. Okay? But you have to have that TED because I got to know about the alternate paths on the network. Okay, how are we doing so far? Am I boring you to tears? Wow. Okay. One-to-one. So we've decided we want to do backup. We're going to now establish this Detour LSP. We're going to take the RSVP session information from the protected path and generate a new path message from myself to the egress router. And as part of that path message, I'm going to include this Detour object. Okay. The important point here is I'm going to stick myself in this local repair node so everybody knows who started it. Right? Because by just looking at the rest of the information in the path message, you can't tell that because you've inherited the main one. Right? So who started it, and then who am I trying to avoid? And I'm going to set this, I'm going to set this inside the path message. I'm going to send it out, headed toward the egress router. So if a detour merge point gets in two path messages from two routers that has the same RSVP session information with different detour objects, it'll just merge that information together. And what you'll end up with is a single path message headed downstream that has two detour objects in it. This path is representing this node trying to avoid router A, and it's also representing second node trying to avoid router B. Okay, so we'll just merge that stuff together. Here's what it looks like. It's a path message, inherits all the stuff from the main RSVP session. That's kind of the key point here. And we throw in the detour object. So here's a merge. Okay, so we saw earlier all these things passing through the middle, head toward the egress router. And when this middle router starts receiving these path messages, it starts to realize, hey, all these things belong to the same session. Got the same session object information, got the same session attribute information, got the same, T-specs, bandwidths, what have you. So it's going to put them all together, merge them together, put multiple detour objects in there, and fling it onto the egress router. Okay, so this helps us save some of that state that we're creating with this one-to-one scheme. All right. So simplifying the network just a little bit. Here's my LSP. We're doing one-to-one, so I've established things. I've merged stuff in the middle off to the egress router. And here are my labels. Okay, so we're doing PHP everywhere. So I got some 3s. My other labels assigned for the main LSP and for all of the detours. So in a normal operation, IP packets come in. We do route lookup on the ingress. We find that it's an LSP, and we slap on 101.456. ship it on down the LSP. We do a label swap, stick on 186.293. Get the penultimate node, we do a pop, we fling IP at the end. Okay. Enough said. Now, what happens when the link breaks? Okay. So we're doing one-to-one, we're doing node protection, and we got a link failure. So, the point of local repair, this guy, the PLR, notices the link failure. Now, how long it takes him to notice the link failure? I don't know. Depends on what happened, right? If it's point-to-point link and it goes down, it's going to be pretty zippy. If it's an Ethernet switch, maybe not so fast. If the downstream node stops responding to hellos, it's going to be even longer. Okay, so it kind of depends. But the PLR knows about the error. It's going to take in this label, 101.456, and it's going to detour it, okay, out to the egress router. That's its job. Take in things and detour. So it's going to do a label swap, and instead of putting on 186, yada, yada, yada down here, we're going to stick on 125.064 and ship it along the detour. Okay. Now, when you get to the middle node here in our particular network, that happens to be the penultimate node for the detour. Okay, so we're going to do a label pop, and we're going to fling IP. If my detour was longer, then every router along the detour path would just be doing label swaps. Okay? It's a single detour path from the PLR to the egress. Swap, 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 pop, and you're out at the egress. Okay? So here's my path error heading up to the ingress router. Now, like I said, as far as what the ingress does, it's up to an implementation. If you have, say, a primary and a secondary path, maybe we'll move traffic onto the secondary path if it's established and tear down this old path with its detours. If we don't, and we can establish another primary path, maybe we'll establish that, move traffic over, tear down this. Maybe we can't find any good paths that we like, in which case we'll keep using this, detour and all. Because a broken but functional LSP is better than none at all in that condition. Okay. But again, those actions are going to be dependent on implementation, software, et cetera, et cetera. A lot of factors that go into that. Now, in a failure mode, as well as steady state operations, we're adding some information to the record route object. Okay, we're going to add some flag values here that's going to alert all the routers along the path as to what's happening with this protected LSP, okay, or potentially the bypass. So, the first flag we have says, hey, local protection's available. So a transit router is going to set that when it establishes its detour LSP. Okay, it sent path message to the egress that got reservations back. Detour is up. Turn on the flag. Okay, it tells all the routers along the path, I have a local protection scheme in place. If I'm actively using that local protection scheme, I'll leave the first one on because it's available, and I'll turn on the second one, which says I'm actively using it. Because it may be that the ingress router decides to keep using this broken LSP with the detours in place. It'd be nice to know that you are in that mode, wouldn't it be? So you can look at, pardon me, the output of the record route object. You can see these flags turned on. If you've asked for bandwidth protection for your detours or your bypasses and it establishes it, we have a flag for that. And then finally we have one for node protection. Okay. We only turn that on when we're doing node protection, right? If you're only doing link protection, you don't turn that one on. But if you're doing either of them, you turn on the first one because you do have some kind of local protection turned on. So is this making any sense? Okay. Facility backup. Okay, again, we've just signaled that we're going to set up a backup paths in the network. And how am I doing that again for facility? What's the method I'm using for that? You guys really are sleeping, aren't you? Oh, come on. The session attribute object. Session attribute object, right? We're going to set some flags in there that says I'd like to do link protection, node protection, facility backup. Okay, so we now know. And based on those flags, we need to do a next hop bypass or a next hop bypass. Now, when we get to that point, we're going to examine our current state in the network. If I am a potential PLR, if I'm a transit or a penultimate router, and I find that I need to do a bypass LSP, I'm going to look for an existing one. Because if I already have one set up that avoids the next downstream link, I don't need a second. I already have one in place. This is the sort of the key concept of the many to one. Okay, all the protected LSPs running across that same link who want link protection will use that same bypass LSP. Okay, single facility, multiple protections. All right, so nothing really changed here as far as labels in my map goes, but what we're doing is facility, and are we doing link or node protection? Link protection. And we're doing link protection. I can tell that because I'm only avoiding the next downstream link. Okay, the ingress router using this nice green dotted line headed here, up and over and up and over. Okay, so we're doing link protection. Take labels in, send them along, send them along, send them along. Okay, nothing really outrageously new here. Now let's talk about failure modes. So now we do have an actual link failure. Okay, so we're worried about link protection, we have a link failure. The PLR, in this case, first transit router, as we had before, is going to notice the failure. Now it's going to get in labels 101, 456. Its job is twofold. First, it's going to do a label swap. And it's going to put on the label for the next downstream node. Label allocated by this router, which is in this case 186.293. Okay, it's going to do that swap function first, and then it's going to do a push. And it's going to push on a label value allocated by the first router along its bypass, which in this case is 125.064. Okay, so here we've got our swap down at the bottom, we've got our push, and we send it up along the bypass. Now, if the bypass is a couple routers long, we'll be doing swaps. In our case, it's 2 routers long. So what's this middle router going to do for our bypass LSP when it receives 125.064? Well, it's going to do a swap ordinarily, but he's at the penultimate router for my bypass. So he's going to pop off that top label and forward whatever's left. Okay, now, what's left, conveniently enough, is a label that was allocated by the penultimate in the first place. So it sees this label come in and says, hey, I know what to do with this. This belongs to LSP whatever. And it's going to do whatever function it's been programmed to do. In our case, that's another pop, because it happens to be the penultimate for the protected LSP. Okay, but if there were more routers along this path toward the egress, it would do a swap and we'd pass it on down the protected LSP. So does that make sense? We're doing a swap and a push. Now, yes? Okay, relationship between labels and inbound interface. Yes. However, if you give me a minute, I'll explain why we can do that. Okay? So let me ask a question here. What if, let's play a little what if game. This is not the ingress router. And what if there are more routers further off to the left there that we don't see? And this router is actually a transit node. And we're doing facility node protection. Okay, we're doing facility node protection. Where are we going to establish bypass LSP from this router here? We're trying to avoid link and node down here, so we're going to the middle, right? And then where to? Penultimate or the egress? To the penultimate, right? Because all we're trying to do is avoid this link and this node. So we head to the middle, we get down to the bottom. Now, in event of link or node failure, take your pick, this PLR has to do a swap, like we just talked about, and a push, and forward information along this bypass. Well, okay, the bypass is 125, 128. I know that. That's a 3. Cool. But how does this router know that this penultimate router allocated 186.293 and is expecting to receive that for this LSP? He's 2 hops away. I told you to remember something. Hey, and what were you told to remember? Record the labels. Okay, we're doing label recording. So every router along the path knows what labels have been assigned by every router. So when I'm doing node protection, I'm going to make a mental note. If I have to put stuff on this bypass, that's the label I got to assign to it. Okay, so for label recording, by default, Junipers aren't going to do it. If you're doing facility protection, either link or node, we'll turn on that flag. Okay, so generally speaking, you're not going to see those on the network. Okay, so that was about 20 minutes. Okay, so again, as far as notifications are concerned, we still have path errors heading up to the ingress. What the ingress does is up to it. You can take its pick. And record route flags, nothing really new here. Okay, nothing really new. Local protection is available. It's in use. Bandwidth and node protection are available. Okay, so as far as the record route stuff and the flags are concerned, that's the same for this and for the one-to-one. Now, back to the question we had about incoming interface, labels, et cetera, et cetera. When we have facility backup in place and we have these bypass LSPs established and we notice a failure, we're going to start sending the downstream traffic, not only user traffic, but also control traffic, path messages, most specifically, through that bypass. That's going to allow the routers along the protected LSP to alter information in their soft state. Things like next hop interface, who's my upstream node, et cetera, et cetera. Okay? So instead of having a protected LSP, ingress, transit, penultimate, egress, we now have ingress, transit, transit, penultimate, egress. From the perspective of the LSP, we've just added a couple of hops. Okay? So the routers adjust that information, and so now we can accept labels from interfaces we didn't know we had before. Okay? As far as upstream stuff, we don't send stuff back up the LSP because we never do that. Right? But we now know with this adjusted information from our path messages who our next upstream nodes are. And we'll start physically and actually, addressing that information, these RSV messages, back upstream to that specific IP address. And we'll just use IP routing to get there. Okay? Yeah? So, okay, so path messages through the bypass, right? No. Good question. This is only for RSVP path information. All the other control plane stuff stays in the IP control area.
Okay, so they would have to rely on their own.
They'd have to rely on their own methods for figuring out there's a link down and reconverging, et cetera. Okay? Yeah, good question.
However, RSVP is dependent on targeting.
RSVP is dependent on the IGP. More specifically for what we're concerned about, it's relying on the TED data. Okay? But it knows that there's a path there, and it knows it has a bypass, so it'll use that in the short term until it can get some reconversion information. Okay? Oh, I'm sorry. The question had to do with whether other protocols besides RSVP are going to send stuff through that bypass LSP. And the answer is no. All the other protocols are going to use just the regular IP routing table. Okay. Now, if you're following along online, the only change I made here is I've taken the sample network slide you'll see in a minute, and I've interspaced it through so that I don't have to back up 20 slides to go back to the network diagram and then go on to my packet captures. So, if you want to move around, that's fine. If you want to watch me, if you want to leave the network diagram on your screen and watch the captures, whatever. It's up to you, but just to let you know that that's the only real difference. So here I've got a sample network. I've got 9 routers. Here are my subnet addresses for each of the links. The loopback addresses are up there, 192 and 68, whatever. Okay. I'm going to be setting up LSPs, one in this case, and just with different varieties of protection, from 32.1 to 16.1. Okay, so I've got transit, and penultimate, and egress router. So the first thing we're going to do is we're going to talk about one-to-one node protection. So from the perspective of 96.1, which is the first router in line here, okay, we'll generally be spending most of our time on this router. Here's the original path message that sets up the LSP in the first place. So I'm headed from 32 to 16. I've assigned the egress router address and a tunnel ID to the session information. It's kind of critical for RSVP. Helps to find the session. Here's my session attribute. Notice no flags turned on. Why is that? Don't I want protection? I didn't turn on any flags. How's this going to work? It's a conundrum. It's an enigma. Is there anything else in here which is not normally in a path message? Fast reroute object. Okay. We have the fast reroute object. That's going to take precedence over the flags. Okay, so we don't bother to set the flags. So here's my source route 6, 5, and 2 subnet addresses. Okay, so it's going to go right across the middle here. Now, if you notice in my fast reroute object, I'm using the default priority values: setup of 7, a hold of 0. I've set a hop limit of 6. Okay, so my detour cannot be more than 6 hops from PLR to egress, with the exception of a merge point. Okay, so if you get merged together, it kind of skews the hop count stuff, because you have to make a decision. If one guy's got a hop count of 2 and he's got a hop count of 4, when you get to a merge point, you can't really make a decision there, so we'll take the longer of the 2. My include and exclude, nothing defined. Okay, so I don't care about any admin groups. This is pretty straightforward. Just get me there. So path message is going to go downstream. We're going to make reservations upstream. So here's the path message setting up the protected LSP. Notice I've got the same session information. Okay, 16.1, I'm the same tunnel ID. I've allocated a label, of course, and I've set up along my strict route. Okay, so that's it. Paths go down, reservations comes back, wham, protected LSP is up. Now, the fact that we included the fast reroute object is going to have each of the transit and the ingress router, for that matter, set up detour LSPs. Okay. So they're going to take, I'm going to go back one slide here, they're going to take this same session information, generate a new path message with that same data, and create their detour and include the detour object. Okay, so here's the original 16.1 and 25.124. If I go to the setting up my detour, notice 16.1, 25.124. It's the same stuff. If anybody were to look at this, they'd think this is part of the original path, 32.1 to 16.1, et cetera, et cetera. The only thing that makes it different is my detour object down here. Okay. That signifies it as a path establishment for a detour LSP. Now, if we look here for a second, I'm branching from 10.2 to 6.1, and I'm trying to avoid 0.1. Okay, so if I go back to the map, here's the router I'm worried about. I'm generating it from this interface, and I'm saying I'm trying to avoid the penultimate link here. Okay. Now, let's take a look at the map here for a second. On this router, I'm trying to get from myself around this guy to the egress router. Okay, I got my TED at my disposal. I'm not worried about bandwidth, not worried about colors, et cetera, et cetera. What's going to be my best path? I got option 1, which is 6, 3, 2, 1, 4 hops. I got 6, 10, 12, 7, 4 hops. Got 9, 11, 12, 7, 4 hops. I got my choice. Cool. You can pick it. It'll pick one of them. In this case, I'm pretty sure we picked the 9, 11, 12, 7 route. Okay. If we look at the detour path, source route, 6, 10, 12, 7. Oh, I was wrong. We went out to the ingress router. Okay. We went 6, 10, 12, 7. So we went out and around this way. Okay. So here's the RSVP message back for the detour. Okay, so we've got our same information here. Record route's the same. Cool. Now, once the protection is in place, what's that router supposed to do? To tell everybody else that protection is in place. How does it signal that to the other routers? Does it just like send them a telegram? Just spams them with some email? What's that? A path error. Not quite. That's for a failure mode. This is just, hey, I've established your protection and it's available if I need to use it. I turn on some flags, and specifically I turn on flags in the record route object. Okay. So, pardon me. From the perspective of that same router, that first transit router, which is 6.1 in this case, I've got a flag of 9. 1, I've got local protection available, and 8, I have node protection available specifically. Okay. 5.2, which is this guy here, the penultimate router, has only turned on a flag of 1. Link protection. Why is that? How come he's not doing node protection? I heard it. He's a penultimate router. Okay? He's a penultimate router, so he can't do node protection. He just does link, and of course the egress router, we don't care. Okay. So that's one-to-one node protection. Does that make some sense? Does it help to see the actual dumps? Okay. So same network, right? Just intersperse the graphic. Now we're going to do facility link. Okay. So how are we going to signal that we want to do protection here? Do we do a fast reroute object, or do we do session attribute flags for facility? My guess is we're doing flags. Okay. Session attribute flag. So here's my session attribute object and a flag of 7. Who can remember what I said at the beginning? What the flag values are? Flag of 7. What does that mean? What am I asking for? Who can read? Link, label recording, SE reservation. Okay. So I want link protection only. Didn't ask for node. Record the labels. Okay, so got to know label information so I can do my swap push. And I want to do shared explicit. Okay. So reservations come back. No big deal. But now we have label information. Okay. Got label information for everybody along the path. Okay, so that's kind of cool. Now, here's my session information, 16.1, new tunnel ID of 25.118. When I go to set up my bypass, notice my session information changes. Changes to the node that it's trying to get to and where it's coming from, 96.1 to 0.1. It's a whole new session. Has nothing to do with the existing LSP. Hence the point of the mini to 1. I'm setting up one new session and throwing lots of stuff on top of it. Okay? So, got my new session, the session attribute, my flag of 4, I want to do shared explicit. And notice that we've created a name for you automatically. I'm doing a bypass LSP, and my destination is 5.2, the next hop. Okay, so this is a next hop bypass LSP. Source write information, et cetera, et cetera. So we send that out into the network. We get information back. Now I'm going 9 and 8. Okay, so subnet 9, subnet 8. If we take a look at the map, we can see that this router here wants to do link protection to avoid subnet 5. So it sends path from itself to 0.1 and uses 9 and 8. Okay, pretty straightforward. Okay, so here's a RSVP message coming back. Everybody's happy. And as we saw before, we're going to turn on flags in record route that says local protection available, flag of 1, flag of 1. Okay, we're just doing link, just local protection. Okay, last but not least, node protection. So before I do this, it's going to be kind of the same. What's going to be the one difference that we're going to see? And there'll just be one between facility link signaling and facility node signaling. Recording of labels, I did that for both, but I'm going to record labels. You're right, I'm going to turn that flag on. I'm going to turn on link protection. I'm going to turn on SE probably, and node protection. Okay, that's really the only difference here. My flags are now set to 17. Link, label recording, SE, and node protection. Okay, that's it. We have new session stuff. We have sources out. We get labels back. Okay, so here's the main LSP setting up. So now we're going to set up the bypass. Okay, so here's the bypass. Notice, oops, sorry, wrong one. Okay, I'm trying to get from myself and bypass the next hop and the next hop. Okay, so this is a next hop bypass LSP. my record route is, or my source route is going to be 9, 11, 12, and 7. Okay, so if I take a look at the map, I'm trying to go from this guy and do 9, 11, 12, and 7. Okay. I'm avoiding this link and this node. Okay, so here's my RSVP coming back for the bypass. We're established. We then turn on flags in the record route option, tell the ingress router. Okay, so here we got a 9 again for doing node and link. Again, the penultimate only does link because it can't do a node, and egress doesn't do anything. So during a failure mode, we're going to see some path errors. Okay. The first thing. Then we're going to see some other flags turned on. So what we have here is between the egress and the penultimate node, okay, we lose a link. So between the egress, penultimate node, so this subnet .4 goes away. We're doing facility link protection. So we're going to receive a path error for this session. 16.1.25.126. The error code technically says I lost a link. I don't know all the codes by heart, so I'm not going to even go there. So we get in path error and we send it back upstream. Okay, so I got it in from my neighbor on subnet 5. I'm going to send it upstream. Neighbor on subnet 6. Same information in the session information. And I'm going to start sending stuff down my bypass LSP. And when I do that, I have to turn on an additional flag in the record route field. If you notice right here, I got a flag of 3 turned on. That's a 1 for local protection available, and a 2 for local protection in use. Okay. So now the ingress knows that not only am I still forwarding traffic in the LSP, I'm doing it via a bypass. Okay, and in record time, about an hour. It'd been longer if you'd asked me some questions. So seriously, any questions? Yeah. Processing time to do all of this and set up all these protection things. I've invoked protection. Oh, okay. You're probably in the millisecond range. The delayed to let the ingress know? Yeah. It's not very long. Mainly it's going to depend on how fast you notice the error in the first place, whether it's a link or just neighbor losing hellos, etc. Okay, it's pretty zippy. But for people that want to make sure, well, there you go. Yeah. Placed in only SONET networks, not necessarily. Could be in a metro environment, depending on how far your LSPs are going to go out from the core. So if you're doing SONET, yeah, it's going to be pretty fast because you're going to notice stuff right away. If not, if you're on a broadcast, or again, if the router has a problem, your next downstream node, that's really where the delay comes in. Other questions? Okay. Do you want me to do anything on the live routers, or do you want to end? We can do both. Who wants me to do something on the routers? Okay. What do you want me to do? Which live routers? Not your live routers. My live routers. Show us how to configure these. Okay, I can do that. All right. So this is, let's see what we got here. Can you all see this okay? Do I need to crank up my font? Humana. You'd think I would have done this before. All right. How's that? Better? Okay. Is it cutting off the side? Yeah. All right, hang on, let me do this. 1 second. How's that? Okay. So right now I've got this guy turned off. But what we have here with this link protection configuration, this is the way that I'm going to signal facility link protection. Okay. When I do this, that's going to turn on the session attribute flags that says I want to do protection, I want to do label recording, I want to do SE style, etc. Okay. Now, there's an additional piece that has to go along with this. Oops. You need to tell RSVP which interfaces to do protection on. Okay, so if you're doing facility backup, you got a two-step process. You have to tell your RSVP interfaces which interface to do link protection for, and that could be both link or node protection, but that's a facility backup thing. Okay, I've just done it for all of them. You can specify just certain interfaces. And once you've done that, then you can tell your LSP to do link protection. Okay. So, if I activate this guy, okay, so he's active. We're going from 32.1. That's what this node is. Okay. This is the 32.1 node. It's in here someplace. And what I really wanted to do was that. Okay, 32.1. And I'm going towards 16. Okay, so I'm headed towards 16. I've kind of enforced it to go through the middle, the 96.1 node, okay, via path. But we're going to shoot straight across the network. Because technically speaking, in my network diagram, I got 3 equal cost paths, right, from ingress to egress. So I want to make sure it goes across the middle. Do link protection. So if I commit this guy, that's not a good sign. What's wrong here? Is there any way for me to know what's wrong, other than there's a problem? No active path. I don't know how to get there. CSPF failed. That's not a good thing. Dun, 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 dun. Okay, I know how to get there. Oh, you're killing me. So, let's go over there. Interfaces, good, and good. Okay. My interfaces are good. So let's go to that. Let's go to 96.1. Oops. Okay. That looks all right. Got 3 interfaces. Got adjacencies. Anybody notice a problem there? How about if I go back up and show you where I'd like to go? Oh! Joe was messing around last night and forgot to return the routers to their normal operating configuration. Hey, you know what? I didn't want to do that. Edit works much better. All right. 1 second. Sorry for the delay. Rename is a wonderful thing. And while I'm at it, yep. Knew I did it 2 places. Okay, let's go see how things are going on my ingress router. We'll get there. Okay. Now I just got to wait for 14 more seconds, which is always an eternity when you're up here like this. What's that? Do I know any jokes? Yeah, but none that are fit for their public consumption. coming, I think. Let me verify. Oops. Cool. Oh, man. Okay. Now I'm really upset. What's that? Yeah, I could have messed that up. All right, let's crutch. So now I don't care how I go. All right, we'll just avoid the node that's not working right. Wow. You'd think I don't do this for a living. Okay. So, can you believe this? It went across there anyway. 654. That's the straight path through the network. Okay. But more importantly, we have label turned on, label turned on. Got a flag of 1 here, so I got link protection. Don't got nothing there yet. Does that mean it's broken? Something's not working. No protection available. So again, he's giving me problems. Show MPLS LSP bypass. This will show you what your bypasses are. Okay. Oh, he didn't update. Okay, that's what the problem is. Let's look at address problems. Okay, let's do this. We will make him cooperate. Let's take him out of the network. Okay. So went across the top, link, bypass. Okay, and the one I care about now is this one that's up. Okay. So this is from the perspective of the ingress router. Okay, let me go back to my record route information. So I went 3, 2, and 1. If we take a look at my network diagram, went across the top. Okay. So I went here, 3, 2, 1. I have a bypass available. Okay. Well, now they're both up. So a bypass to get around 3.1, and I have a bypass to get around 10.2. Isn't that nice? There's some detail on there. I can see explicit routes, record routes, etc., etc. If I go to the current egress router, now he's also set up for link protection, but we don't want to do that. Let's do node protection on this guy. Okay, so here's my current config. I'm going to take out my primary, so I don't hopefully avoid the problems I just had. Oops. Path, testing, primary, use, whatever. And I'm going to set node link protection. Okay. Now within RSVP, you still have to have the link protection command turned on. But within MPLS, this says facility node protection. Do the node and the link. Okay? So let me activate that guy. Do a commit, cross my fingers. So my ingress is up. Okay, so let me just narrow down to that guy. Okay. If I do my bypass, it is also up. Okay, so I'm going from myself to 48.1. So from the ingress router to 48.1. And the way I get there is, I have the detail option here. Explicit route 7, 12, 10, and 3. 7, 12, 10, and 3. Kind of weird, huh? What node did it pass over on its way there? The egress node. Oh well, that's life. Okay, because my job is to get you from myself to the next hop, and that's what I did. Now, the reason it didn't stop there is because we have different session information. The bypass is a different session than the LSP. If they were the same, we would have realized, whoa, wait a minute, this is the egress, let me stop here. But we don't. Okay, so I had to go all the way through. So yes, we will forward packets all the way around to here, spin around, and shoot them right back at the egress router. Okay. So to do facility, you need link protection configured on the RSVP interface. Then you do either link protection or node link protection at the within the LSP definition. Okay. Now to turn on one-to-one backup, it's fairly straightforward. Let's go to a different router here. Let's go to, this is the guy in the bottom corner. Show interface church loopback 0. Okay, 80.1, which is this guy here. Okay. So let's set up an LSP going from here to say 48.1. Okay. So set protocol MPLS, label switch path, Bob. Most things in my world are Bob, or Joe Bob. 192.168, 48.1. Please set label switch path Bob to do fast reroute. That is one-to-one node protection. Okay. We do a commit. Ingress detail. And we're up. Okay. First hop did node protection as requested. Here's my 9. Oops. Here. Next guy did a 1. Okay. If I do my show MPLS LSP bypass, nothing there. Because I don't have bypasses. I have detours. Okay. Let me, instead of doing detail on show MPLS LSP, let me do extensive. So here we originated the call, path reservation, got a record route, made it active. Then we created our detour path. Okay, then first router notified us of a change in its record route, protection available. Then the second router recorded a change in its record route. Okay, so the detour is up. The way we see the detour is by looking at the session information. Oops. How about just do a detail? So here's my main session. From 80.1 to 48.1, pardon me. Here's my sender and receiver port numbers. That's what locks in the session information. Here's my original record route. Now I have a detour. Okay, detour's up. Pardon me. Went 721. This is detour branch from 12 to skip 48. And I also had a detour branch from 10.1 to skip 48. Merge them together. And they went along this path. 12, myself, which is also 12, 712. Okay, so the detour, because it's associated with the session, gets shown with RSVP session. It's tied to all that same information. No bypasses in place here. Okay. So the configuration is pretty straightforward once you get your IGP running correctly. It's interpreting all of this that's the real challenge. So, Does this make sense? At least configuration-wise? Cool, straightforward? Okay. What else would you like to see? Pretend I'm a trained monkey. I do lots of tricks. Break a node, okay. So right now, I have got okay, my record route is 12, 10, and 3. So I got 12, 10, and 3. Okay, up along here. So let me go to this router here and deactivate this interface. Okay, tear this down. So let me head over there, and I'm looking for subnet 10. Yes? Oh, you actually want like to do some pings and stuff?
Yeah.
Wow, you're really complicated. Okay. 1 second, we can do that. I got to set up a bidirectional one, come the other way, and then I'm going to advertise them in ISIS is what I'm going to do as a quick hack. Label switch path. How about Fred for this guy? 192.168.80.1. Okay. Now, within ISIS, I'm going to now advertise the LSP as a point-to-point link. Okay, so label switch path. So label switch path, Fred, and I'm just going to leave him at the default metric. Okay. Actually, let me make him a better metric. Level 2 metric of 5. Okay. So commit that. Let me go back to my ingress node and do the same thing. Within ISIS, advertise Bob, a level 2 metric of 5. Now, if all works out correctly, we now have an adjacency between those two routers for ISIS over those LSPs. So now I should be able to ping my far end, which is 848.1. Cool. But did it really do what I wanted it to do? Sure did. It's over the LSP. Okay? My forwarding path over the LSP. So we agree that we're using the LSP. Okay. Can I also prove that with the trace route? Label, label. Cool? Okay. So let's do this and see if we should happen to lose some. So I'm just going to leave this running in the background. Let me head over to this guy. And I'm looking for subnet 10, which looks to be on FASTE 002. So I'm going to set 002 to disable. And as soon as I commit this, it's going to tear down that interface. We should be doing some rerouting, etc., etc. Head back to this guy. That's not good. It's dead. Drat the luck. So, let's think about this for a second. I've got, let me widen this up here. I have got LSP, which basically looks like a point-to-point link between these two routers. Now, tore down this guy, this fast Ethernet interface. Theoretically speaking, we got path error messages up here. And we should have done something. So let's ask that router what you did. Bob is up. 7, 1, and 2. With the other direction. We have ISIS problems. So it didn't work out like I really wanted it to. In a perfect world, we'd have traffic stream flowing through. I'd kill the link, no packets lost. Okay, but it's not a perfect one. Sorry. Sydney is this bottom guy down here, 80.1.
So what is it about the ISIS?
Well, when I do it in ISIS, now I don't have to worry about adjacencies. I got to tear down the adjacency, reset up the adjacency, et cetera, et cetera. Whereas if I did it in BGP, which would have required more upfront work to get it running, then I wouldn't be relying on reconfiguration of ISIS and things like that.
So what would be the steps for
Oh, if I were going to do this full time, I would be doing it with BGP. Okay, I'd be forwarding from myself to some FAR node for BGP routes.
So in order for this to work, you have to do some.
In order for it to work really well, yeah, you need to have a little bit more pre-prep time. And flying by the seat of my pants, I don't have it. So, okay. So now that I'm like 1 for 3, anything else? That's a good batting average, by the way. 1 for 3. Just not so good when you're taking an exam or something. Okay. Well, let's call it a day. Thank you very much. Feel free to shoot me emails for questions, feedback, constructive criticism, flames, what have you. Okay, thanks.